All right, we have a survivors here that survived the networking and coffee session. This device does everything except for making coffee, as I know now. Looks very impressive, doesn't it? So you'll show how this works, right? Kari and Atis is they are going to show the case in the end of their presentation, so it must be really interesting. So from the office to the field and hopefully back again. Sorry. It happens. All right, gentlemen, the floor is yours.
Okay, thank you. I hope you can hear my voice. Everybody's awake and good mood. All right, in this session, I'm going to demonstrate to you how to operate with the building information model to the field, how to lay out these points, or we can say also set out these points and these features that comes from this model to the field. And a few words from myself. You have heard the name of, and I'm not going to read it again. I'm trained as a land and engineering surveyor and operating approximately 20 years in a building construction, infrastructure, different kind of application of surveying, including land and industrial surveying. Some paper machines are really familiar to me. So my idea is here to convince you that I know what I'm talking about. So that is the idea. Also, nowadays I have been working 13 years in Finland in a Trimble distributor, Trimble authorized dealer, as they say officially. As a salesman, of course, that's a very important thing we do. And also the support and training are the main areas where I work nowadays. And with me is Atis Wallis from the local Trimble distributor. He will assist me with the total station demonstration in the end. Would you like to say a few words, or?
Labdien! Es pārstāvu SIA Geostar, kas Latvijā piedāvā Trimble instrumentus, risinājumus, apmācības. Un šodien uzstāsies kolēģis no Somijas vairāk.
So I ask Atis also to join us because he is the local, he can speak local language, so he can answer your questions fluently, more fluently than I can do in your language. But first of all, the agenda, what we are going to show, how does this system and what we are showing here, how does it actually work? What are the benefits? What are the requirements of that? How this thing looks like from the point of this Tekla structures. I have always difficult to remember Trimble or Tekla. It used to be Tekla, now it's Trimble, but they are producing Tekla structures. This one takes about 15 minutes. The next thing is, who is doing this? After this session, I hope everybody in this room will be doing this more or less. I don't know if you already have anything to do with the surveying at the site, but you probably know somebody in the site who is doing the actual survey, or you actually are giving the jobs to the surveyors in the field. But I'm trying to convince you that it's worth of going to this direction. And finally, we have the live demonstration with Atis and with this instrument which doesn't make coffee, but it makes everything else. And we will ask or give you a chance to ask questions if you like in the end of the presentation. Maybe if you notice something and want to ask during the presentation, it's okay. We will answer as much as possible. Okay. First, how does it work? Now, the surveyor gets the building information model, as we call it, constructible model from the site, and gets the surveying task. Okay, you have to do something. You have to stake out some points from this, or some structure from this model. There are two roads to the success, as the topic says. First, okay, you can use the layout point workflow in the Tekla structures, pick up the points, pick up the details from the drawing, or actually we should call it as a model. Use the layout point applicator plus layout manager in the software, and also transfer that data with the USB memory stick or similar way to the field computer. There are several different applications in the Trimble field computers that can be used in this case. I will show in the end one choice. The next route, it will be using also the layout point applicator and the layout manager, but push that information to the net, to the Trimble Connect, which you have been heard probably today and will hear probably more in the future. This is a collaboration platform manufactured by Trimble or defined by Trimble, and there you can connect to this system with the Trimble different applications, different field software, if you like. So basically, in a big picture, the system goes like this. From the model, you pick up the points, you pick up the features, details, whatever you need, collect them, put to the field computer, and then the field computer guides the total station to go out and set out those points and those features. But is that enough? I would say no. The next phase is to collect the as-staked information. What is the quality of that stakeout method? Are we within a tolerance, within a few millimeters, within a centimeter, within 5 centimeters, depending on the nature of that structure? Also, the very important thing in a site is to collect the information which describes the as-built information. After some casting of concrete has been done, you go there, a surveyor goes there and measure the position and the dimensions of that piece of structure, and also collects that information and puts that back to the documentation, which is actually the quality document. We will show that later on. So this video shows some examples from the building, from the model. Okay, there are several tools where you can go and find out with which IFC class, for example, these bad footings do belong. You can create a stakeout points, list of points automatically to the top of this foundation, top of the footing. You can go to and collect the strip footing in this case. Collect them from the model, all of them. Then you can do several other things. You can go to show these collected points, or maybe some other important features that you want to stake out, or give the surveyor to be staked out in the field. For example, some holes to the slab. Sometimes they are very simple, like in this case, they are a really simple shape. Just the holes where you can basically use a traditional methods to go and make them. But in some cases, they are quite complex. Imagine to do with a measuring tape and a theodolite, these ones. You would find that very difficult. It can be done, but it's time consuming. And also when it's time consuming, it's also money consuming. Then very important parts of the building are the anchor bolts. And those are sometimes maybe the most precise features in a building construction site that has to be staked out very, very carefully. But after picking these points, picking these features, you will open these in a layout manager, in the Tekla structures, and select the points and operate with them. Finally, you will export the points to the text file, which is transferred either to the Trimble Connect or directly to the field computer. Then after the surveying task has been done and as staked or even as built information is collected, you can bring that file back to the layout manager and load that file and see immediately where actually the real bolt positions are. So you can decide now whether it's good or whether some changes has to be done. Or even send a message to the factory that, okay, you have to change something in this column that is going to be built here, going to be installed here. So I mentioned about Trimble Connect, which is the collaboration platform for all kinds of construction sites. It will connect the design, or in this case, the model, constructible model, through the cloud, through the field computer. And this one happens by internet. How many of you have ever seen this Trimble Connect in action? It's completely new. Good. I will suggest that you will start learning about this one, because this is really a future of a collaboration of this information. And this Trimble Connect connects also the surveyor, actually, to these constructible models. And one thing I want to highlight is this documentation here, which is actually the as-built or as-take documentation, which is the key to the quality estimation that you might have received, or your surveyor has received on site. Also, you can do several different tasks in the field. One example here is this floor flatness, which is quite important when you're finalizing the floor. For example, floor like this one, which has to be quite even, quite solid, quite stable. And if it's not, then the quality is not exactly what you are ordering. If something happens that you cannot collect all the points from the model, you can also take the design or the model itself to the field computer and do some point picking in the field. This example comes from that world. So now we have explained how to do it, and then we have to explain and want to explain who is doing it at the moment. As a background, from my building construction surveyor, I used to use, in early ages we used paper drawings, which was official. I guess they are still used in some cases in most countries, because they have to. There have to be paper drawings for officials, for building permissions or some other meaning. After, I would say that in early 90s and mid 90s, the drawing files became, the CAD drawing files became in the future, into the real life. We started to use them. The problem on those days was that, the CAD drawing, it looked okay, but the drawing elements were not in the precise, exactly with the dimensions that were supposed to be. The dimension reading, the number of that dimension text was okay, but the length of, for example, one line was not accurate enough. So that delayed a little bit, a few years maybe, about using these CAD drawing files. And if I would have imagined those days that something like three-dimensional model would come, I would have been really happy to see them in the future, in real life, in the working site. But anyway, who is using these today? There are several examples around the world. This one comes from the US. It's a construction site where, for example, there are several different columns or different features which has to be built before the actual frame of that building comes. You can imagine to use these. Well, it's a small dot, but hopefully you can follow. You can imagine to build these with the traditional methods. Of course it can be done, but is it accurate enough? Is it productive enough? The string line is okay for very small areas, small buildings to use, but it's time consuming. It's also the weather causes sometimes a problem. Wind can bend the string line very easily. so you get a straight line. You want to build a straight line, but you cannot. It's going to be curved based on the wind. Or then there is a water, whatever can be. And a plumb bob is, do you know what the plumb bob is? Some of you might know, yes. It's the one that is hanging down, giving the impression that which is the vertical straight line. That is also very easily bended by wind or weather conditions. You can imagine to use those features here, building up these ones. Now, it doesn't happen today because you are using a robotic total station to do it. This one doesn't matter about, it doesn't care about the weather, whether it's like. If it's pouring rain, okay, then surveyor will be inside in that case, of course. But anyway, in any other circumstances, it will be used. The next example is from Finland, very close to my office where I work. This one shows very clearly what is the building construction or the bridge construction environment in Finland. The bottom brown layer shows the hard soil, where all the piles will stop when you hit them into the ground. It's all clay and very soft clay around it. But you still have to build a bridge there, because there's a road design going along, and the bridge has to be connected to that one. But also, the surveying tasks, one of those is to define these places for the piles. Also, the bridge construction is quite complicated, because there are lots of details, lots of very accurate details, and also the bridge shape can be very difficult. It's not straight, first of all. It's always connected to the road alignment. And when the road alignment is straight, it's maybe some places, but not always. It can be bended in different shapes anyway. And there's one joint, for example, in this case where the balls red, circles are red, balls are, that is very precise place which you have to, with the surveyor has to set out very exactly. But by using total station, using this model to pick up these points, you always can be sure that you will get the correct positions. You never do the calculation by your hand, which is also good way, good traditional way, but it also is a source of some mistake. You can make mistakes in there. 10 millimeter mistake is sometimes very hard to see. 100 millimeters is even harder to see. 1,000 millimeters is disaster. But okay, you can send these points to the instrument and go and stake out in the field. Then another example comes also from Finland. As you can see, there are some details on the facade, or there will be a facade. There's going to be aluminium frame for facade glass. And before these frames are manufactured, or before they are sent to the site, you have to be able to check that all the supports, all the connection parts are in the right position and in the right location anyway. By taking these features from the design, from the model, and go on and check those, you will get you can be sure that these frames which are going to be delivered to the site will fit in this place. Then piling is sometimes quite difficult or easy to do, or sometimes the piles doesn't go exactly to the position that where they were supposed to go. In this case, you can see the red and green shapes here defining the points where the actual theoretical position of the pile should have been and where the actual as-built pile position is. The sooner you get this information to the designer or whoever is doing the foundation designing. If the pile is misplaced, for example, 10 centimeters, which can happen, then the framework has to be designed again. You will use more concrete, you will use different shape of the rebars. If you prefabricated rebars, you have to do something about it. And sooner you can change the plans, the more money you can save. Then another thing with this one, the manhole and the pipes are showing is the collision detection. If the pile standing next to the manhole or this would have been 10 centimeters misplaced, then the complete structure should have been rebuilt or redesigned. Then again, I was talking about the anchor bolts and anchor bolt locations, which are very important in this building construction. And I guess these are one of the most precise parts of the building, usually the tolerance within a few millimeters. So as soon as you get the information to the design or to the site where the actual position of these anchor bolts is, the sooner they can react or make other plans if needed. This is one of my favorites. Architect has decided to build a stairway like this. And what comes next? The group of carpenters asking the surveyor that, okay, we want to build this one, would you help us? What can you do? You will start from the model. Start picking the most important points where this stairway structure will be, and take those points to the formwork. And carpenters are happy. They can go and build this formwork, and the final result looks very fine. I would imagine I wouldn't like to do this one with the traditional methods. Okay, the measuring tape is very good, the theodolite is very good, but it will really take some time to do it in the site. This one actually has been done with the total station, a robotic one. So this one is quite a good example of those. Architects are very good of creating very nice shapes of the building. As we saw in the first session, that there was it Louis Vuitton Museum? Really nice. I like that. This picture is about to show that what different type of the structure, what different type of details you might and you can get from this design, from the model. As you can see here, everything in these buildings nowadays, they are not in a straight angle. There can be some 30 degrees, 60 degrees, something else than 90 degrees or 45 degrees. But the shape of the building is not a box anymore. And the more complex they go, the more you need to be able to get from the actual structural model. As you can see here, the shape of this bad footing is not straight angle from the main footing here. Again, one of these examples from the real life is from the robotic surveying. Okay, in a model, this one looks okay. It's complex, but it's pretty simple. The thing that the model doesn't show is the real life, the circumstances in real life, how you build these things, how you are going to measure anything in these potholes or between these two potholes to get these pieces of foundation or these details as accurate as they has to be. You can imagine using theodolite here. Okay, maybe you can see some parts of this pothole, but nothing in here at all. But here the surveyor using the extended prism rod, and he can go to the deep bottom of the pothole and make the markings that has to be done. In this picture, there is another application that total stations are used within a construction, and it's called monitoring. The monitoring, have you ever heard about that? Or maybe who has heard about monitoring? 2 hands at least. Good. Monitoring is actually the following the existing structure, how it behaves when people are operating or working around that building or piece of structure. It can be an old building, or it can be a wall or historical building or historical thing. And the total station is following the position of the prism which is connected to the structure. And whenever there is any movement that more than it was supposed to be, the system gives an alarm, and the job can be cancelled, and people can go there and investigate what can we do, what has to be done. There are not so many sites that there are 3 different total stations working in this meaning, but in some cases, yes. Okay, now we are ready for the live demonstration. And the thing we are using here, I will change to the different software. This is actually the software which is guiding this total station and operating with that one. You can see the position of the total station is here, and this red dash line shows where the instrument is pointing in this coordinate system of this design or this plan here. If you're working in a 2-dimensional way, you can see only this, nothing else. If you want to go and do something, you will get the list of points, and you don't know what actually this means. But when you are using 3-dimensional information, you can rotate it, you can have a look about, all right, looks nice. Yes. So, to get started, this is the first point, and I'm asking my colleague Atis to go, and I will start doing the stakeout. Okay, the prism is locked, and the system is guiding Atis to the correct position where this actual point is going to be, or this footing will be. And as soon as we're within a tolerance, I will small adjustment. We have to be very precise. We want to be precise with this one. And store. So, this is the information that is stored from this stakeout. Okay. Good. We go to the next one. It's about a meter. So this is the display that the surveyor can see. This is made for very simple, very precise, very guiding where you have to go to be able to stake out that position with a very precise way. We can also here see that, okay, there is some difference in elevation which has to be taken into account, of course. But in this case, okay, this is a plain place where we are going to build, and I will accept this one and store the results. Then we can go a little bit further. As an example, take this point and go and stake out again. As you can see, the robotic total station, the name robotic comes from the instrument itself, or the system itself. The robotic total station is following that prism that Atis is holding in his hand. It's an automated workflow. So actually the surveying group is only one man or one woman. We have to take consideration of course that one also. One person, I would say, officially. With a theodolite and a string line or measuring tape, you always need 2 persons to operate. Okay, this one is fine. Storing the information, and one more point. Getting close, getting close, getting close. Yes. All right. The first part of the job is done. Then we want to go and stake out the other line of the foundations here. Let's hope that it stays on this area, not go to the middle of the chairs, but we will see. Stake out, okay, we'll see. Maybe you have to move a little bit further that way. Or there's another thing in these systems nowadays. We can use the video, on live video. Okay, the blurry of this video comes from the rate of the video image, which is actually sending from the instrument to the field computer. It's actually the refresh rate is 5 times per second. It's always to use just to follow that where the surveyor is helping him to find the places. I can show you what is actually the meaning of the camera inside of this instrument nowadays. Sometimes it's very complicated because normally you are facing yourself towards the instrument and have the display here. Now you have to look the display over there, so it's. But we are getting to the good accuracy now. Okay, stored as staked. Then we can, okay, make it quicker, go to this first position here, and getting closer and closer, and finally a little bit of adjustment. And normally we put nails on all of these points, but in this case, no. We didn't want to do that. Okay. Almost there. All right. I'll store this one just by purpose. If you stay there for a while, I will show something. I was talking about the video image of this. Actually, there is a camera chip inside of the instrument, as nowadays there are mostly in these robotic instruments. And the reason why the system is there, why the image is there, is of course the following the instrument, following the prism. But another thing is to take a photo from the instrument, which actually gives you the quality. More about the quality report, more things to go to make to the quality report. You can open these images. You can see that the quality is something else than was in a video screen. Actually, the quality of this image is, the pixel size is 5 millimeters in 50 meters, which is really good. And really, it's in a coordinate system. It's in a very precise, documented. You can grab actually the measurements from these images nowadays. That's another technology. Okay. Thank you, Atis. And then the next phase is to get that quality information from this job file. So I will export custom format file as a stakeout report. I can put here some tolerance values which I want to achieve and see how these points were staked out. I have to view also the created file, okay? So here you can see there are some points which are within a tolerance, but also there are some points which are not in a tolerance. So this is now alarming bell to the surveyor or foreman to show that, okay, something has to be done here. Okay, so this was my ideas and my message to you about how to operate with this constructible model with the robotic total station. And If you have any questions, please go ahead.
What is your customer practice for usual things, let's say civil things or cast in place or precast? They're using that probably. But what else? What other areas? Do you have some practice maybe, I don't know, for pipes, for some other equipments? How to find, what's maybe a little bit expand ideas, where to use that?
Well, everywhere, basically. It can be used also in a pre-construction, pre-design, taking the measurements from the existing structure and take those measurements to the design phase. Then you can build or start to build a new house, for example, next to another one or things like that. You can measure a surface model from the ground and start placing a house there. There are several places to go. In a technology which comes into the building, or if the technology needs very precise set out, stake out, you can use even for that one. The accuracy of this instrument is sub-millimeter if you are within a 10 meters range from the instrument.
Sounds very impressive. A bit more precise than the coffee machine. Any questions? If not at this point, we can meet you in the exhibition hall, I believe.
Yes, we are in the exhibition. Atis is going to be there also, and colleagues from Geostar will be there. So.
All right. Thank you, gentlemen, for this. And yeah, that's the part where you do this clapping thing.